Hi, I made this video to talk you through the review exercises for Chapter 10. So I posted this review sheet on Canvas, both the version without the answers and the version that you're looking at now that does have the answers. And if you totally understand everything that's going on in all of these examples, you don't need to watch this video. But I'm making it in case there's anything that isn't totally clear just from what I have written here that I can help explain for you. If we were still meeting in person, we'd go over these problems in class. So this is kind of the next best thing to that, I'm hoping. So notice the directions. Simplify, assume that variables represent positive real numbers. The square root of 4 over 81 is, well, the square root of 4 would be 2, the square root of 81 would be 9, so we get 2 over 9. The square root of 7 over 9 would be the square root of 7 over the square root of 9, and we can't do anything more with the square root of 7, but the square root of 9 is 3. For the square root of 25x to the 12th y squared, we can break that down into the square root of 25, which is 5. The square root of x to the 12th power is x to the 6th power. Remember, x to some power, and then you take the square root, you get x to that power divided by 2. And that's because if you started with x to the 6th and then squared that, you'd be taking x times x times x times x times x times x times another x times x times x times x times x times x. So x to the 6th squared is x to the 12th. Therefore, the square root of x to the 12th is x to the 6th. And the square root of y squared is y. Now, if I hadn't said assume that variables represent positive real numbers, then we really ought to say that the square root of y squared is the absolute value of y. But since I said this, you don't have to worry about that. Number 4, the cube root of 27 p to the 3rd q to the 12th. So the cube root of 27 is 3. The cube root of p cubed is p. The cube root undoes the cubing. And the cube root of q to the 12th power is q to the 4th power. Notice how the power gets divided by 3. 121 to the 1/2 power. Now that does not mean that we're multiplying by the number 1/2. It means we're taking this to the 1/2 power, and that means the same as taking the square root of that number. So 121 to the 1/2 power is the square root of 121, which is 11. 1000 to the 2/3 power. Okay, remember what happens when the power is an exponent. The denominator of that exponent tells you what kind of root to take, and then the numerator tells you what power to raise that to. So 1000 to the 2/3 power, we take the third root of 1000, which is 10, and then take that 10 to the 2nd power and get 100. X to the 2/5 times x to the 8/5 power is x to the, here we add the exponents, and this didn't come through real clear. It looks a little like a minus sign, but that is a plus sign. X to the 2 over 5 plus 8 over 5 would be x to the 10 over 5 power. And since 10 over 5 is just 2, the answer is x to the 2 power. W to the 5/6 divided by w to the 1/6. So here we're going to be subtracting the exponents. This is w to the 5/6 minus 1/6. So that's w to the 4/6. And 4/6 simplifies to 2/3 because you can divide the numerator and denominator of that fraction by 2. These say write in radical form. So we're starting with something that's written in exponential form with an exponent, and we're going to write it in radical form with a radical sign, some kind of root. So z to the 1 over 4 power would be the same thing as the 4th root of z. The 1 over 4 power is the same as the 4th root. And 10x to the 2/3 power would be the same as 10 times the third root of x to the 2 power. It would still be okay if you put the second power outside the radical sign. It doesn't matter whether you take the third root first and then the second power, or take the second power first and then take the third root. But the 10 is not affected by the exponent. The exponent only applies to the x, not to the 10. So the 10 should not be under the radical sign. It should not be raised to a power. Number 14, use a calculator to approximate the square root of 59 to 3 decimal places. Okay, now most of these I'm not looking for a decimal answer, but here we are. So different calculators do square roots in slightly different ways. Make sure that whatever calculator or whatever calculator app you're using, you know how to do square roots on that calculator. So make sure you try that and get this number as a result. Here is one example of doing this on one kind of calculator. To get the square root on something like this, I push second and then the squaring button that has the square root sign above it. And then I put in the number that I want the square root of, 59. And then I hit enter, and the square root of 59 is 7.681. And then there are more digits after that, but it's set to 3 decimal places. So some calculators work this way, others work other ways. Make sure you know how whatever it is you're using works. Number 15 says to simplify. Now here we do not want to use the calculator and just plug in the square root of 162. It will give us a decimal number, but that's just a decimal approximation, and it's not what we really want if we're saying simplify. So 162 is not a perfect square, but we can factor it so that one of the factors is a perfect square. So the largest perfect square that we can factor out of 162 would be 81. We can write 162 as 81 times 2. So the square root of 162 would be the square root of 81, which is 9, times the square root of 2, which is just the square root of 2. And the square root of 12x to the 9th power. Same sort of thing, but here we have a number and a variable part to deal with. 12 is not a perfect square, but we can factor into 4 times 3, and then we've got the square root of 4, which is 2, times the square root of 3, which has to just stay as the square root of 3. And then for the square root of x to the 9th, now be careful, if this was just the number 9, the square root of the number 9 would be the number 3. But the square root of x to the 9th power, x times x times x times x times x times x times x, did I say 9 of those? We're going to break it up, factor out the biggest perfect square, which would be x to the 8th, times one more x. So we've got the square root of x to the 8th power, which is x to the 4th power, times the square root of x, which has to just stay the square root of x. So after we have pulled as much as we can out from under the radical sign, we end up with 2x to the 4th times the square root of 3x. For the next problems, the directions say add or subtract if possible. And this first one, 7 plus 3 times the square root of 5, that's one that isn't possible. We can't combine those because they're not like terms. One of them involves a square root of 5 and the other one does not. We're not allowed to add before we multiply, so you can't just add the 7 plus the 3. But we can combine number 18. 7 times the square root of 5 plus 3 times the square root of 5 equals 10 times the square root of 5. Just like 7x plus 3x would equal 10x. Here it's the same kind of thing, only instead of x, we have square root of 5. Then number 19, 10 times the square root of 20 minus 3 times the square root of 5. We can't combine those the way they are now because the radical parts are different. But we can do something with the square root of 20. We can simplify that because we can factor 20 into 4, which is a perfect square, times 5, which is the other factor. So for the square root of 20, that breaks up into the square root of 4, which is 2, times the square root of 5, which is still just the square root of 5. So now we're looking at 10 times 2, or 20 times the square root of 5, minus 3 times the square root of 5. And now these are like radicals. We can combine them. Just like if we had 20x minus 3x, that would be 17x. The 20 root 5 minus the 3 root 5 equals 17 root 5. And number 20, we have the square root of 4 plus the square root of 21. The square root of 4, now 4 is a perfect square, so we can go ahead and say what the square root of 4 is. It's just 2. We can't really do anything to simplify the square root of 21. 21 is not a perfect square, and it doesn't factor into any factors that are perfect squares. So once we get to 2 plus the square root of 21, we can't do any more than with that. We can't combine these, so that would be our final answer. Okay, so that's it for the problems on the front page. I'm going to end this part of the video here and then come back, and in part 2, we will work through the problems on the back. See you then.